Hi, everyone. I feel like I've done like a roadshow today. It's like done all these introductions, also track hosting, and now giving a talk. I really jumped at the opportunity to give this talk because chaos and resilience engineering are two of my passion areas. And I've spoken on this topic before in the past. So thank you to Nora for also giving me this opportunity. I just want to say I feel a bit like I'm the warm-up act before the main headliner at this event, because I actually spoke on the same track last year, right before one of my other industry heroes, John Allspaw, and I'm doing the same this year before Nora. But anyway, I hope you enjoyed the talk. So today I'm going to talk about both some of the chaos practices that we use at Condé Nast, which have been running for more than 2 years now, and also incident management. And also about probably an often overlooked, but even more important aspect, which is about growing the resilience of your organization in the face of adversity and failure as well. So I'm a VP of engineering at Condé Nast. I've been there for just over 3 years. I look after their global strategy and operations for technology and engineering. And you'll see in a second kind of a picture of what we do. So you might be like, who's Condé Nast? So we are a portfolio company. We publish more than 30 different publications around the world, both in print and in digital. Here's some well-known brands that you might recognize. So we have Vogue, GQ, Wired, Vanity Fair, Glamour, The New Yorker, Bon Appetit. I mean, the list kind of goes on and on. There's more than 30 brands in our portfolio. And there's this kind of wild, sorry about the animations, but I think like it gives you kind of a sense of our global footprint in terms of our company and what we have to try and serve around the world. And so when I say more than 500 million customers, I mean, I'm like, is that requests or customers? Because I can't imagine 1/16 of the world is actually looking at our publications every month, but apparently so. This is a bit old, actually. We're now in about 40 countries around the world, and this is just kind of giving you a taste of what publications run where. And what underpins this is sort of a Kubernetes platform that we've been building for the last 2.5 years. That platform itself runs about 10 clusters at the minute, and we're running in 5 geographically distributed regions, namely in Japan, China, Frankfurt, Ireland, and US East 1 as well. So we run on AWS as well. So I'll just go into what we're going to cover today. So we'll talk about like what do we mean by complexity and what do we mean by resilience, because I think these are two not always well understood terms when we're talking about this in terms of software. I'll talk about how we've embedded some of the chaos practices from chaos engineering and some of the tooling that we've used as well at Condé Nast so that you can see how you might want to do this for your own organization. And incident analysis as well. I'll also use a real-life case study of an incident that happened at Condé Nast only a few months ago and kind of go through how that played out and kind of some of the cues and some of the signals that you might see during that incident, which are often, again, overlooked, because often we focus on very technical aspects and come up with very technical actions, but we need to kind of go beyond that as an industry. And then, yes, finally, stepping beyond the tooling and thinking about how do you grow human resilience within your organization. Because we work in dynamic socio-technology sort of systems, we need to think about both the technology that we build, but also the humans that have to operate that, essentially. And how can we make that easier for them? Yes, and how are we evolving our practices? So what do we see, how are we evolving that internally in my own company, but also what are we seeing in the industry as well? So I don't know if you saw the talk by Luke Blaney at the Financial Times. He's a principal engineer. And I told him I'd do a bit of a shout out because I love the start of his talk because he kind of goes, this is our tech stack. No, wait a second. It's like this. Actually, it's like this. And it's like, I feel like the same thing can be said for Condé Nast because as I mentioned, we're a globally distributed organization. We have 12 international physical operations. And the tech stack that runs in each one of those locations is different. We do have one global platform that we've now managed to roll out, which was no like small feat. But this is only a very small part of the kind of technologies that we run today. On top of this, in terms of application stack and CDN, because we mainly are talking about web here, web applications, is Node, React, JavaScript, and we use Fastly mainly as our CDN provider. but we also operate in really difficult places like Russia and China. So we've had to actually use some very specific technologies and be a little bit more agnostic in order to interoperate. So I just want to point out as well, so a lot of people think about legacy as a bad thing. I don't know if I see it the same way. Like, we'll always have technical debt, like the first line of code that you write is going to exist for longer than you can ever expect. But I see it more like legacy is the cost of success. Like, it means that your company didn't fail really early on, and that, over time, that's going to accrue, and you will have to manage that in some way. So I just want to pick a really apt quote from one of my favorite books, which is called Drift into Failure by Sidney Dekker. He might have been mentioned on the track already. Sorry, I haven't been on all the talks. And the talk is, complexity doesn't allow us to think in linear, unidirectional terms along which progress or regress could be plotted. He is a part-time professional pilot, so I think he's got quite the deep requisite knowledge in order to talk about complexity and resilience. And I would definitely encourage you to go and reading this book. It's amazing. It's very eye-opening for me. But what he's saying here is, like, it's really difficult to predetermine whether you can't really predetermine whether something has had a good or a bad outcome. It's hindsight. And therefore, we end up with lots of bias in our industry around hindsight. And we're like, oh, of course, you see a timeline of events and you're like, of course this is why this happened. Of course, that's why that person made that mistake. But again, like, the way that we build applications, or the sort of distributed nature, the very dynamic nature of them, both in terms of humans and sort of the technical systems that we build, that's not true. If you think about that more deeply for more than a couple of minutes, you realize that it's not a linear thing. And another thing I've been getting into a lot recently is systems thinking. So I'm going to have a couple quotes in my talk around a book by Donella Meadows, who a lot of you might have heard of. She wrote Thinking in Systems, a primer. And she talks about, like, thinking about more, like, holistically. What are systems? Where do we draw the boundaries? What are the actual mechanisms and feedback loops? She talks about things like stocks and flows. Where do we get things like bottlenecks? How can we make things more efficient? And how can we sort of leverage the best mechanisms to make our systems more efficient and successful? And these are just a couple of sort of screen grabs here. There's this one stock system is actually an example in one of the first few chapters, and obviously you can imagine it gets a lot more complex than that, but it's really interesting. Again, it's a book that I'd really recommend because it's very accessible. She doesn't talk in very technical terms. She tries to use everyday things. Like here, she's talking about a heating system, or she might be talking about how even a coffee machine works as well, so that it's really accessible to any audience. But also, like, there's posts around the internet, and this is a person that I really like, Will Leithane, and he talks a lot on his blog about system thinking, and you can kind of see how these concepts then apply to the work that we do day to day, and what kind of feedback loops and mechanisms there are there. So please go and read that too. And here's one of my favorite quotes from the book. So it says, because resilience may not be obvious without a whole system view, people often sacrifice resilience for stability or productivity, or other more immediately recognized system properties. So this is something we'll be diving into a little bit more later in the talk, is like, how can we have more of a whole system view so that we don't focus potentially on the wrong, like over-optimizing on the wrong goals when we're developing software. Okay, so next subject, I want to talk a little bit about like chaos engineering and what we've been doing at Condé Nast. So we have been practicing chaos engineering in some form for more than 2 years. Before that, I was a principal engineer at the BBC, and we also did some chaos engineering there, so I took some of that practice with me into Condé Nast. And I just want to do a myth busting. So chaos practices won't completely eradicate operational surprises. A lot of the reason why we did it was to try and build resilience in people, basically, and get them more adjusted and used to having to deal with things in the moment of surprise, which is often a very stressful time, but also being able to think very critically and logically in that moment rather than panicking. And here's another one as well from the primer book. So think the bad news or the good news, again, hindsight bias, is it bad news, is it good news? Is that even if you understand all these system characteristics, you may be surprised less often, but you will still be surprised. So what kind of tooling and architecture considerations did we sort of look at? So this is from a talk from a couple of years ago. I ripped it off of a talk called by Adrian Cockcroft, who's one of the VPs of architecture at AWS. And he tries to get people to think about, okay, what's your system, what's your stack, and where might you be applying different types of tooling or even processes in terms of actually experimenting effectively across your stack. And so one thing that we use quite heavily here anyway is Gremlin, and it is more of an application, an infrastructure stack sort of experimenting tool, but it also does some application level fault injection, which I'll talk about a little bit in a second. Apart from that, we don't use a lot of tools, and I'll go into why later. I think as an industry, again, we can focus too much on tools and forget about like the actual craft of devising experiments. And also, we generally have access to things like CLI, so we can probably, break stuff pretty easily. But anyway, here's some takeaways if you want to go and have a look yourself. And also just thinking about how we have evolved our architectures over the last couple of years as well. Thinking how we've gone from physical machines more to virtual machines, containerization, and serverless. And so you might want to consider this and also look at the context of your own organizational technology sort of estate and work out where best to apply this kind of tooling to what kind of context. So as I mentioned, there's some notable tools. I've put a link here to one of the posts that actually lists all these tools as well. Like I said, one of the main dominant players is Gremlin, and that's the one that we use. One of the key reasons why we use them as well is because it's very accessible for product engineers to use a tool like Gremlin because it provides a very friendly UI, and it also offers an API on the CLI as well, which they can access quite easily. But again, if you feel that your engineering organization is more experienced and can do these things without a UI, then go for it. So one thing that we're looking to introduce at work, and we haven't, it's not finished yet, is that we're also introducing a service mesh. Because as I mentioned, we have about 10 Kubernetes clusters running all across the globe, kind of managing that kind of communication in sort of multiple regions, but also multiple clusters, pods, everything. We need some way to manage that in a better way. And so we're looking at using something like Istio at work at the minute. And there's been quite a new tool come out, so I don't know if many of you practice chaos engineering, which is called Chaos Mesh by PingCap. So this is something I would, again, take away and go and look at. It's not something that we're using yet because we haven't fully implemented our service mesh, but it's something that we probably will end up using. And just kind of moving along a little bit, so like, also give some consideration to whether or not you're using serverless, because I think the patterns that we use there require probably a different thinking, but also different tooling as well, in terms of how you want to apply chaos testing to that. And I'm just zooming a little bit through this because I think, like, you can go and look at these slides. I will publish them afterwards, but a lot of it's just linking to things that already exist. A really great person, if you want to know a lot about chaos engineering for serverless, is Gunnar Grolsch. I put a link here to him. He does lots of demos, but he's also built a lot of tooling in this community, and he actually does a lot of talking on this as well. So now let's get into something I find a little bit more interesting. So like, how do you devise your first game day? How many of you here are actually running game days, or have run? Wow. I didn't expect so few people to raise their hand, but anyway, it's not that scary, it's not that onerous. So the way that we started, just to like make it seem, again, less scary, is that I thought, okay, well, let's just get loads of people in a room. And that's what we did. So we got lots of people from product management, Scrum Master, so delivery management. We have an internal function called IT service operations and engineering. And I said, let's get, and engineering, of course, is comprised of lots of types of specialism. So that includes things like cloud infrastructure, SRE, product engineering. Yeah, those were the main ones. And sort of got like about 20 of us in a room. And I said, okay, well, we've devised, so we did devise, oops, sorry. Oh. Gosh, it went quite. So we devised some scenarios, and so we called it Theorycraft. That was quite a good name. And this was our very first scenario, and we ran this in early 2018, and it says, an image has gone missing on the Vogue UK front page. Every time a customer loads the page, instead of the image, they see a blank box. This may have caused an increase in 500s, which has been reported by the load balancer and triggered a page. I think it's supposed to say like reload or something. Customer complaints editors and engineers are all sure to notice in the next few minutes. The on-call agent has just received the following page. Vogue UK 500s per minute, and it's, sorry, C rocket runbook. So it says what happens next. So anyway, so we that's all the information we gave them. But before that, we had devised, like, how do we want to run incident management in our company? And we tried to get people to follow this process. We even devised things like decision trees to try and get people to understand, like, how does this flow in the time of crisis? And it was really interesting for a lot of reasons. So I'll go through a couple of things that happened. So I'm just going to have a quick drink. So the very first thing that someone said, I said, OK, what should we do? And somebody said, well, why didn't one of the SREs like already? Why is it coming in like this? Why didn't they just get pinged first? Why is it that customers are coming through and complaining first? And then somebody else in the room said, well, they should just get fired. And here I was like so smug, thinking I had built this amazing culture, blameless culture, and this was literally the first thing that someone said, and I was actually just shocked. I think actually I went quiet at that point for a few minutes, and other people took over. But actually, no, the first thing I said was, no, nobody's getting fired. No, you know, this isn't the way we're gonna do this. Like, it's a blameless culture, which again, if you look at blameless culture, it's still about, it's basically creating psychological safety, but also giving the people accountability as well. So you have to balance both things. So it's not that people are fully unaccountable for breaking software, but also you want to give them some safety as well. And then we went through this, and the interesting thing that I found was that people were jumping off the process. So it was like step 1 was good, then suddenly they were on step 4, then suddenly they were on step 7, and then they jumped back to step 2. And it was like, well, who's the incident commander? And it just became really unclear. So like I said, there's so much tremendous value just doing this. Like, you don't need to go and instrument anything. You don't need to go and set up anything. This is how we started, and this is how we ran it many times, because I was like, until people internalize the process, I'm not really sure what value it brings by adding lots of tooling on top. I'm not really sure what we're solving. And so, yeah, then, you know, we had other scenarios that we ran through as well. It's like more realistic scenarios, like an etcd desync. And we had some intended expected outcomes. I can't remember if we shared that with the group or not, but we're kind of seeing like whether or not sort of what we thought the troubleshooting path would be would match what they actually went through in that workshop. And then so we've run some more recent game days as well. So we had one thing I want to say as well is, like, I know the pain of trying to even get buy-in to do these things, because we actually went through a bit of a break ourselves. So just a bit of context about Condé Nast, we actually went through a merger last year. So we have a US company and an international company, and we actually merged early last year, and so this kind of went on a bit of a break while that happened. But luckily, we are actually running them now pretty much every week. And this is one of the ones that we started running quite early on this year. So this is, Departures is our internal CI/CD platform. It's got it's a full stack thing. It's got a UI on top. It has APIs underneath. It actually, can hook into things like Jenkins or Circle CI or Concourse. It can hook into several sort of CI/CD workflows underneath. But it just makes it really easy for, again, everyone, all product engineers, who don't necessarily have the deep infrastructure knowledge, and nor should they always at a certain scale, to be able to deploy really easily and see the sort of feedback from that as well. So anyway, so this was like, okay, how can they follow things like runbooks? What kind of other artifacts might they look at? This is a failure. And we also had things like an in-hours and out-of-hours process as well. And like, how would people follow these processes differently if it was in hours or out of hours? And we could see that people were actually just getting a lot better, actually. But also, at the same time, we were also trying to spread this culture into our US company, which hadn't been doing this kind of practice to date. So this becomes like a global practice for us now. And it's kind of almost like a mandated thing that all engineering has to do now. And here's like just some examples of like things like the actual conditions of the experiment. So we kill the cluster, it's called Sabre, or the cluster scheduler, sorry, it's called Sabre. And the expectation would be that our departure CI/CD platform wouldn't show any available builds, and it would block any type of deployments happening until that's fixed again. And so again, because we've set up the conditions in advance, we can now see if those expectations match actually running this experiment. And to be honest, again, we can just go in and kill that. We don't need a tool like Gremlin necessarily to do that. So, like I said before, our systems are complex. And so one thing we wanted to start thinking about was like, how do we, there's a lot of types of testing. And like, how can we try and run these experiments in a more end-to-end way, particularly when we're serving a lot of requests as to users, and that has to go through multiple layers, different types of caching, request tracing. There are different parts in the stack in which things can fail. And so we wanted to look at something like our service map, and we use Datadog quite a lot still. And this was something that it gives you as dynamic service mapping. And this is just a snapshot from actually early last year of part of our sort of microservices, the microservices that we have within our ecosystem. And just trying to understand what are the actual connections and coupling between different services themselves, and trying to create experiments off the back of that. So again, that's something that I would actually really encourage as well, is thinking about how do you go from experiments which are quite, you have to start simple, but yeah, they need to grow in complexity over time, just like your systems. And then this is actually taken from a really great blog post from Cindy Sritaran. Like, no talk of mine would be complete without a call out for her. She's amazing, but she also does a lot of really amazing sort of articles around, request tracing and getting people to think about like, okay, well, there's multiple different paths in which that can execute. There's happy paths. There's kind of a thing called sad paths as well, and making sure that you think about your failure cases or edge cases and try and capture that in sort of a request response system. And that other diagram might look quite the same as this one, which is actually Amazon's XRay service dependency map. So again, like you can probably get this from different tools, but again, if you don't have this available, like this is a place to start and to start thinking about how to devise experiments around this, because this is actually the customer journey that you're basically devising experiments around. And I think I just showed that one, so I'll skip that. So, is your organization ready? So this is a great tweet from Charity Majors. Again, she does a lot of talking on this subject. Her company, Honeycomb, is really interesting. We don't use it ourselves, but we've been looking at it like, how do you move away from sort of tracking more raw events instead of doing log aggregation, and using things like she mentions here, high cardinality to sort of index things and to be able to find them, find trends and variances a lot more quickly. So she says your org is ready for chaos engineering when you're able to budget your reliability work instead of performing it reactively. And when you have enough observability, and that's why she's mentioned it's not monitoring, to reliably identify the chaos you have injected. I think this is a really important point. Like, don't inject chaos if you literally can't observe what the fuck just happened, because otherwise it's just chaos. And there's no point in doing that. So think about that. But also I think it's really important. The other key point here is around trying to, so we didn't have an SRE practice until only about 9 months ago. It took quite a long time to get that off the ground. And the key thing for me was trying to find a really solid lead engineer to kind of come in and actually spread that practice and build that practice in the organization. But one thing that has allowed us to do is that, it's now within their remit. It's the expectation that this team can help us have that capacity to do things like reliability work in a more proactive rather than reactive way. Okay, so now I'm going to take you through an actual case study or the actual outage that we had. So I didn't mention this before, but we have a multi-tenanted web application. So it serves multiple sites. And so sometimes when things go wrong, it can take down several sites at once, which is what happened in this case. And this is like kind of a view through what happened in Slack, because I like to just silently observe what happens and just see how people react. And yeah, I like the human side of it, but also like where are they looking? What kind of artifacts are they using? What are they saying to each other? How are they sensing out what to do next? And so here's our cloud platforms channel at work. And as you can see, somebody says, OK, I'm seeing DNS errors coming from Rocket, Rocket being our web application. And then somebody's saying, OK, well, I'm seeing some 503s here. But it looks like I can't see the same thing happening in Datadog. So is it the CDN, Fastly? Like, where's the problem? So now they're trying to find where do we think this is stemming from? And then more and more people start to get involved, and they're looking, OK, I found some artifacts. Like, there actually are some graphs here that we have available to us to try and determine what's going on. So now we have an 8.5% error rate coming through. And like, that's 13% if you include the 404s that are happening at the same time. So that's fairly high. Something's definitely going wrong. So yeah, and then I think the interesting point here at the end is like we're continuing to investigate, but without an owner or someone with domain knowledge to make the call. I'm not comfortable making this a P1 yet. Engineers are continuing to investigate the outage, and that was probably somebody from IT Service Ops saying, I don't know what to do next, and it seems like I don't know who to contact in order to make a judgment call about what we do. It's bad. So here I annotated this as well. So like here's an initial punt at the hypothesis. A lack of instrumentation in the app. So we use Datadog APM quite heavily, but there's other types of instrumentation we put in there as well. And this is like a way of enriching the context available to the humans that are looking at this. Like, here's a graph. And I think this is great. But like, also don't overwhelm people with graphs as well. Like, people love graphs. It's kind of insane. Like, I remember, even actually at Condé Nast, I can't say it happened at one company, but I went into Datadog recently, and I was like, there's like 50 graphs on this one view. And I'm like, I don't really know what I'm meant to be looking at here. like some of them made sense. Some of them I was like, I don't even know why they're on here. So that was another thing that we actually I put pressure on them, was like, can we clean this up, please? Like, if you really need them, put them in a different view. It doesn't need to all be here in one place. Because I said, in the time of crisis, people just don't have enough capacity to look at all of that information and kind of make sense of it. So here we go. It keeps going. We eventually get to a point where we create what we call an incident room itself, so a dedicated incident room, because we don't want to clog up the cloud platforms room, which is actually a shared public channel across the company, which people that aren't even technical join, but also there is other ongoing stuff that people want to ask in that channel. And then you can see that people are starting to move across to that channel. So there's some more things that are shared. Here we go. We've created a separate incident channel. Just going to try and do this. So here we're capturing some more data. So I thought this was quite interesting. So somebody actually added, so it wasn't like an automated thing. Somebody actually added some stuff. Somebody's put note for postmortem. APM for Rocket is not instrumenting React router routes. And I thought that was cool, that somebody actually put that in there so that we could capture it later in terms of our postmortems or incident analysis. And they're thinking ahead, like, we want to capture this. We probably want to create an action off the back of that. So that's good, because it's kind of like they've been trained over time to do this. And here we go, like, we can start to see, like, okay, well, something's going on, some sockets here. Maybe this is starting to create some actually cascading failures for us within our web application stack. So somebody needs to probably go and have a look at this as well. We also have other things that run in our environments. So one thing I'll talk about later in the talk, which I feel quite pleased about, is that we have things like shadow trafficking that we use in order to mitigate the risk of deploying experiments, essentially. But we kind of you can see here they're shutting down all these non-essential things in both non-prod and prod environments. And this is my favorite. Engineers are drawn to incidents like moths to a flame. So like, suddenly there's 4 people in there, and this guy is meant to be on holiday. He's got the beach icon, and he's like, he's going in anyway. He's going to go and have a look. He's probably going to start getting involved as well. It's like, just enjoy your beach holiday. Forget about it. It's fine. It's just websites. So anyway, so then after all of this time, I like this as well. Somebody offered yet another hypothesis because they were given more context. They've had more time to think about what could be going wrong. So this is really cool. And then we have some things that actually come back as more like an automated set of data that we can also capture in our postmortems. But as you can see, there's more people joining. We've got like 7 other people still joining this channel. So I think in the end, we ended up having 30 or 40 people in this incident channel. It's like, why? It makes things worse. And I think that Laura talked about this in her talk. Sorry, I didn't get to see it because I'm running another track. But I think that it's really critical. It's like, how many is too many? Is a good question. It's one that I would like to know more about, and so hopefully I can speak to Laura about this later. But I often see it as well. That in itself, people wanting to help creates sometimes more chaos. Yeah, anyway. This is also how I feel in a lot of these incidents. Yeah. Right, so and I'm just going to run through a couple of graphs. So these are some things that we have in terms of like artifacts that we can kind of use in terms of like determining where things are going wrong. But also they're not so interesting because you'll have your own things as well. But this is like, okay, what's most important to look at as well at any given moment when you have an incident. So yeah, so we use Trayfit quite a bit, so like a reverse proxy for Kubernetes, and we were seeing some things here as well. I also quite like, I'm not trying to do like a Datadog sales pitch, but I quite like they give you things like flame graphs as well in terms of like sort of mapping your request lifecycle and seeing where things are taking the longest to sort of to complete. And again, another shout out to Cindy Srutaran is to try and think about like this again in more holistic terms, like how there's so many types of testing, and kind of think about like your holistic. How does this fit in to the way that you do testing at your company? But also like trying not to be scared of testing in production. I'm a big fan of this because I see a lot of reluctance in this space. And I'm going to talk about a couple of the techniques that we use at Condé Nast in order to try and mitigate that risk and kind of mitigate that kind of fear that people have around this. So as I mentioned earlier, this is an actual syslog from our traffic, which is one I found on the internet. But we use Fastly, and it exposes the syslog directly. So we can hook straight into that, and we can get our traffic, and we can replay it in another environment as if we take production traffic and replay it in another environment, which is a like for like of production. For us, this gives us a fair amount of certainty around whether or not things are going to go wrong before we actually have it running in production. So look at things like this, traffic replay. It's becoming more of a common pattern. Another thing that we do is different deployment strategies. We actually do a lot of canarying at work. You might have different deployment strategies. We use feature flags really, really heavily. It maybe is somewhat easier when you work in a company like Condé Nast, which is a publishing company. Things are heavily cacheable. It's not a high frequency of change. But we use that both in terms of running chaos experiments, but also we also run about 200 experiments a day on like product features that we ship as well. Like we'll say, we'll send this, we'll switch on this feature toggle for 10% of traffic on X website for X feature. So again, like if you already have that kind of thing in your system, then these concepts won't be that, that sort of unusual. I think about how you do that as well. And canarying is a really great way of, again, mitigating fear and risk around breaking things. So I don't know if he's here in the audience, but Colin Breck gave the talk around Tesla yesterday, which was amazing. And I took one of his quotes from his blog post series, which is amazing, so please read it. And I said to him, like, if anything, I came away feeling like sort of really sold on functional programming, which I wasn't expecting because of the title, but it was amazing and very, very well articulated in terms of concepts. But he talks about things like, even with, say, a Kubernetes ecosystem or infrastructure ecosystem, there's a lot that could go wrong. There's a lot of dynamic parts to it. There's a lot of message passing, things happening at different times. So sort of, again, not linear and not very deterministic as well. So think about this as well. So like things could go wrong in different parts. Okay, so my favorite parts. So we talked a lot about like how do you get started with chaos and some ideas around that. So this is about building human resilience in an organization, which I actually feel is one of the most important parts. So again, another quote here from Thinking in Systems is, "We are too fascinated by the events that systems generate. We pay too little attention to their history being key, and we are insufficiently skilled at seeing historical clues to the structures from which behaviors and events flow." So I think like if you want to think about like, people will often ask that, why did that happen? How did that happen? Often they're looking for a short-term clue or a set of clues. But it really takes like a sort of historical context to kind of get away from doing things like hindsight bias, essentially, and making short-term determinations about things or judgments as well. So again, like just think about this quite heavily. And I don't know if this got mentioned in one of the other talks, but I love this post as well, which is like, how does human work actually get done? And an alternative root cause analysis, which I think is a little bit bullshit, root cause analysis. And just don't worry, everyone at work still uses it, and I'm trying to beat this out of them, but they still use it. But it's kind of describing like different ways to think about how humans work. So there's work that you imagine that you're going to do, and you have your own mental model of what that's going to be. Maybe you can even play it out in your own head. There's work as prescribed for your company or your manager or from other places. There's work that you disclose to others, like things that you've done. Could be like that you've drawn a diagram that you want to share, or even how you described a solution that you did. And then there's actually the work that's done, like how you actually did it for real. And this blog post goes into quite a lot of deep detail around this and like why this is important, because it is like a Venn diagram. There's some overlap, but there's some distinct differences. Like the work that you imagine in your head isn't going to be 100% fully shared with everyone. The work that you did is not going to ever be 100% shared with all the humans that you work with. Their mental models will not always align with yours. And this is very important in terms of incident management and wanting to do things like chaos engineering or building up resilience, is just being aware that part of the reason why we ran all these experiments and these game days and these theorizing around different things was to try and align mental models as best as we could. But again, our systems are dynamic, so they will keep changing, so that information gets out of date very quickly. So I started to think, like, how can we turn, so we do postmortems, incident analysis, all the time. Like, I'm very sort of hot on this and make sure that they do this. But how can we actually turn those actions into more like hypotheses and experiments that we can run? It's all very well creating actions, but it's kind of like they get put in confluence, which is like where best intentions go to die, essentially, in my mind. And so, like, everybody knows that. Like, so it's like, how can we actually take this and turn this into something tangible and something that's actually useful, that maybe will uncover more things, and maybe we create more actions, because we like creating work for ourselves. But it's really important as well. And so, like, one thing I also found from reviewing a lot of their actions was that they're very technical. Like, it's very technical and very specific. And again, it felt very root causey. Like, it's like, well, this particular pod did this, so therefore we're going to scale this up, and it's going to fix everything. And I was thinking, like, well, we need to probably step beyond that again. Like, it's fine to have technical actions in there because we have technical systems. But, like, I think, like, something that's often overlooked would be something like this. Like gaps identified in architectural knowledge, like getting somebody to do rotation. So we actually had some product engineers do rotations through both our cloud platforms teams and our SRE teams, specifically for this reason. Both to bring them that kind of, like how might a product engineer use the products that, because ultimately SRE teams and cloud platforms teams still produce products, even if they're technical. Like, how might they use them in terms of a user experience, but also bringing that knowledge back into the teams, the product engineering teams as well, and making sure that knowledge is more shared around the organization. Yeah, the thing around incident management flows, like, I would say just keep repeating that as much as you can. And when you have new people, they also need to be onboarded in some way. And I'll talk about how we onboard people as well in a second. And too many graphs, too much information, information overload. I don't know where to start. The cognitive load on the people is too high. So how do we turn that into a more realistic set of information for the people that are on call? So this is what I was talking about just now. So we have something now called On-Call University, where I work. It is mandated, so all engineers must join this. And I think it's great. We only just started it 2 weeks ago, and we've run it now twice. And it's meant to, so when somebody joins our organization, they don't go on call like straight away. We tell them, obviously, in the interview that this is an expectation. But we want to train them up a bit, and it takes some people longer than others. Sometimes it just is like, it could just also be a personality thing, like how comfortable are you with, things that are, can be quite challenging. It could be like how much experience you have as well, but it's a mandated thing. Like within 6 months, we want to make sure that people get onto the on-call rota. So it's like about providing also ownership around alerts and incidents, because I think that's something that, again, that a lot of companies, ourselves included, have historically done quite badly, especially as people join teams, move teams, organizational shifts. You need to make sure that you have consistent ownership there. And then knowing like what's expected in terms of on-call. And of course you get stickers if you do this, which is amazing. And then we've also started sending out an SRE weekly newsletter as well. So it's good having a team established again, like I said before. We're lucky to have that. But also it's kind of like organizational change is really important too. Like it's all great if engineering's doing some great work, but we kind of want to share why this is important with the rest of the company and what we're doing to track this stuff over time, and kind of the health of our services and our applications. And it's kind of like an internal marketing / selling, if you want, to try and say this work is really important. It's not wasted. It's not, some science project that we just dreamed up. And we have different things in there. So this has grown. So we've been running the newsletter for about 5 months. So we've iterated this quite a bit. So like this is something, the very first thing I said to the SRE team is like, can we please clean up our legacy alerts? Because we got to the point where people were just ignoring alerts when they were on call because it was fatiguing. We had too many alerts. And so as you can see here, I loved the way that they did this as well, to say, in red, these are all the legacy alerts, and here's the new SRE alerts. So what we actually fundamentally feel is important in terms of a customer-related goal, not just some ping that you get because there's a 500 error here, or 400 or whatever. And then this has evolved over time, as I said, so we can kind of follow the trends over time, think if we're doing better or worse. Sometimes it just depends. We might launch a new product, so that might also have an implication there too. And then we can also track risks in terms of how high priority they are for an organization as well. And then the very last thing is like we started also doing I've started thinking also about dynamic artifacts. Because I think what's really hard, having been an engineer myself for a very, very long time, like almost 20 years, is that one thing that I see time and again is like we create artifacts, but they get stale straight away. And because of the dynamic nature of our sort of socio-technical systems, it's sometimes difficult to know how interactions work, who knows the most about what, who's got the most domain expertise. And so these are a couple of things we're looking at the minute in terms of what we're doing at Condé Nast. So we have something called RDoc, which is more like a dynamic way of outlining your technical architecture, and it has an API which is hookable, so you could actually change things more dynamically there, and it gets us away from using Confluence too heavily as well to track our technical estate, which is also good for onboarding new engineers too, like making sure that that information is always really fresh. And then we did some static analysis late last year in terms of working out through GitHub how different teams commit to different repositories and who commits the most, who pair programs with who the most, just trying to work out relationships and trying to create a more dynamic maintainership model as well. I think that Nora might have a little bit more to say on this, because as she was talking to me yesterday, she was saying, we might think that just because somebody's committing a lot of code to one repository that they're the expert, but that's not always the case. But for us, it's a good stepping stone. Anyway, and I just want to go back, do a quick recap, and I think we're done. So complexity and resilience, trying to talk through what do we mean by this? Resilience, more importantly. How do we use chaos engineering at Condé Nast? Hopefully it makes you feel a little bit more able and less scary in terms of being like something you can actually start doing at your own company today. We went through a case study. Like, how did that happen? What were the cues, the signals, the different artifacts that people were linking to? What should you be paying attention to in terms of when this happens in your own company as well? And then also about human resilience, like how to grow that within your own company and how to advocate for that too. And then like thinking about how we're evolving our own practices internally and kind of moving to, how can it be more dynamic and making sure that things are really fresh and making sure that everybody is on the same page in terms of doing things like on-call university and sending out like weekly newsletters as well. I think that's it. So thank you very much for listening to me.
Awesome talk. Thank you so much, Crystal.
Thank you.
So we have a couple minutes for questions. Do I have any in the audience right now?
It's okay if nobody has questions.
So when you're doing your game day analysis, is it just working on the incident that you're talking about, or does it include the retrospectives and postmortems? And do you just say, well, here's what we should do next time? Like, do you capture all that data as well?
We do. We try to look at historical information to inform like the next set of game days. It won't be the last thing that's happened. We tend to take, like with any postmortem, we can take up to like, say, 20 actions, and then we might prioritize those a little bit. But then we think about, like I said before, like it's all very well saying, okay, we're going to fix X, Y, Z, but it's more interesting to think about, well, how can we turn that into more like an experiment that we can actually run through? So we do look back at historical postmortems to try and draw those kind of things out.
And is that also, sort of a meta question, influence the next game day as well? Like, how do we do the game day better?
Absolutely. Yeah, it does actually, that's a good point. It does capture, like, how could we actually improve together, like as a team, actually troubleshooting an incident. So that's what I was mentioning there before as well, as like capturing not just very technical actions, but also more human-focused actions and process actions as well.
Other questions for Crystal?
Oh, okay, good.
Do you also consider any cost implications around spending time versus the downtime of an application or a website, etc.?
Downtime in what way?
I mean, specifically if you're trying to do game days on production environments, maybe have an implication of downtime? How
like
running
an experiment around that?
Yeah, running an experiment on production means a downtime for a customer.
We've done that.
Somebody.
We have done that.
Okay.
So I think like some really, really advanced companies do things like they can deploy experiments through their pipelines. We don't do that. But we have run experiments on production. But like I mentioned before, when you have mechanisms like things like feature flagging, or being able to route traffic to a certain percentage, it really helps. Because then they call it minimizing the blast radius, essentially, in terms of like who's actually impacted as a customer. But we have run some you have to get to that point, really, if you really want to go and get really sort of more robust with your chaos testing. You need to test in production. Yeah.
Just checking time. Okay, we are at time. I'm sorry.
Thank you, everyone.
Thank you, Crystal.